Good afternoon. My name is Geraldo Morales and I'm accompanied by my partner Marcos Pesante. We are part of the research group in charge of Professor Gerson Bocham called Variable Command Response Type Rotorcraft Control System. The helicopter is the most versatile and maneuverable aircraft design. Unfortunately, it's one of the hardest to control since they're not stable by nature. For this reason, modern helicopters offer automatic stabilization and different types of flight commands. These control systems are typically implemented in electronic computers. Autopilot is an open source community that offers support for autopilot software. For an RC helicopter, it contains the necessary controllers to be able to maintain a stable flight and for different flight modes and flight commands. In this project, 4 different types of flight commands will be designed, tested, and implemented on a small-scale helicopter. These are rate command, attitude command, velocity command, and position command. At a long run, the whole purpose of this project is to develop a multi-axis RC helicopter control system with a variable command response type, allowing a broad set of operators from the highly experienced to the novice to easily control and maneuver the aircraft. Operators will have the flexibility to manually select the response type depending on the desired mission and operator skill level. In this way, the success rate of a whole range of missions will be better and easier to acquire. Our current objectives in the project are to adapt our autopilot flight modes to 3 of the 4 desired flight modes already mentioned. The acro flight mode, which corresponds to the desired rate command flight mode, the stabilized flight mode, which corresponds to the desired attitude command flight mode, and loiter or pulse hold mode, either of which correspond to the desired position command flight mode. The acro flight mode allows for fully acrobatic drone flight. In the stabilized mode, if you let go of the sticks, then the helicopter will remain level. The loiter automatically attempts to maintain the current location, heading, and altitude. We want to test the implemented flight modes with the helicopter to see if they work properly. We also want to assemble a second helicopter as backup because we have already learned that things don't always go to plan or as expected. Now I leave you with Marcos.
Thank you, Gerardo. So the last time we were able to test the helicopter, we began testing Autopilot's stabilized flight mode, and we were able to use it successfully. We proceeded to then test Autopilot's brake mode, as it is intended to stop the helicopter on situations where it loses control. These vary from situations where an unexpected gust of wind hits the helicopter to occasions where testing a flight mode for the helicopter fails. However, Autopilot's brake mode did not operate as expected. It should change its attitude to compensate for outside disturbances and maintain its altitude while it ignores any control stick inputs. Nonetheless, as soon as this flight mode was activated, the pilot lost control of the helicopter as expected, but instead it almost fell to the ground and moved sideways. An incident was prevented by quickly switching it to stabilized mode, which had already been tested. After further research, we found that Autopilot's brake mode depends on loiter flight mode's controllers, which in itself is aimed towards changing the helicopter's position using control sticks. The main difference between these two flight modes is that brake mode intentionally ignores these control sticks. Unfortunately, we were not able to test loiter mode in time. Another problem we noticed during reunions in the lab is that the altitude hold flight mode was also not working as expected. It should enable the control of the helicopter's roll, pitch, and without affecting its altitude. However, we ran a test where we turned the helicopter on, calibrated its sensors while on the second floor of the building, and we observed how the blade's attack angle changed as we took it to the first floor. We saw that the blade's attack angle did not change at all, even if the helicopter successfully measured the change in height, and the swash plate responded to changes in pilot inputs and changes in the helicopter's attitude. This problem is worth diving into since some of the flight mode's features are used by the loader flight mode. Despite all of these problems, we have been able to make some progress. We have been able to update the control stick's throttle curve and have been working towards identifying other key elements necessary to implement both loiter and pass hold flight modes, two basic but essential flight modes which will help us achieve our desired position command flight mode and make the brake mode work as an additional safety measure. Regarding the throttle curve, it is a measure of how sensitive the control sticks will be at different positions and can be configured to achieve multiple sensitivities and gain more efficient manual control over the helicopter. The helicopter, whose model is the Align Trex 500X top combo, had some preferred configurations in the manual which were then configured into the control sticks. These were the 3D flight curve and the general flight curve. A third customized 3D flight curve was added in order to resemble the graph you can see on the left more faithfully, as the resulting graph in the control sticks did not bear noticeable resemblance to the graph. This new configuration still needs to be tested. The next time we test the helicopter, we can test the loiter and pause hold flight modes since we have done some research on the parameters we can tune depending on the errors that emerge. Finally, our future plans involve continuing to research and to start testing the stabilize, altitude hold, loiter, pause hold, and brake modes. Once again, these modes are basic, but essential flight modes that will contribute to implement the desired flight modes and to develop the RC helicopter test platform with features in mind. This way, any future developments that may arise either from implementing new control strategies to simply testing new flight modes may be tested securely. Additionally, we plan on reviewing the helicopter performance during test flights and change any necessary parameters in order to accomplish a successful final test flight with the different flight modes that were previously mentioned. Thank you for your attention.